Hi folks, this is Kareem Raouf for IT Visualizer channel. We will continue our lab, the matrix lab. This is the video number 117. I've been discussing in the previous video the following. We have seen that when I fed up Claude AI with some documentation talking about troubleshooting Windows operating system and application freeze, we have seen how he has explained this topic through these PDFs and PowerPoint presentations, and how he had made head-on exercises to explain this topic. And I have said that there is a third way to explain topics. I asked him to explain this topic using a learning dialogue between a senior IT and a junior IT. Let's see how he will explain Windows operating system and application freeze using a learning dialogue. So let's see that. Just wait for a moment, guys. So let's continue, guys. Let's see the dialogue or the learning dialogue. As we can see here, this is Windows lookup and freeze troubleshooting, a journey from confusion to mastery. This is like a story or like a dialogue, and it has characters, and it has some scenario or something to explain the freeze topic. Let's see how this will be explained. As we can see here, this dialogue is of this case is so long, but let's try to read it out loudly.
Ulf. But speaking of next steps, let's set up that virtual lab environment I promised so you can practice these techniques. Windows lockup and freeze troubleshooting, a journey from confusion to mastery. The Frozen Help Desk. Characters. Marcus Thompson, Senior IT Administrator. 20 plus years of Windows server administration experience. Known for his methodical approach and ability to solve complex problems. Explains technical concepts through correlated analogies. Maintains a personal collection of troubleshooting scripts called his toolbox. Measures troubleshooting time in cups of coffee. Came up through the ranks during the Windows NT/2000 era. Zara Chun, Junior IT Administrator. Former computer science teacher who transitioned to IT 8 months ago. Visual learner who creates mind maps for complex processes. Enthusiastic and takes detailed notes in a color-coded digital journal. Working toward her MCSC certification. Brings a fresh perspective and organized approach from her teaching days. Occasionally gets overwhelmed by the sheer number of troubleshooting tools. One hook. Monday morning, 8:15 a.m. The IT department's open workspace is quiet except for the soft hum of computers and the occasional beep of a network switch. Marcus sits at his desk, reviewing weekend logs while sipping from a mug labeled TCP/IP. Try coffee protocol/immediate pour. Zara, rushing in, slightly disheveled. Morning, Marcus. The finance department is having a meltdown. Their accounting application keeps freezing during month-end reporting. 3 users called already, and the CFO is threatening to revert to spreadsheets if we don't fix it today. Marcus calmly takes a sip from his mug. Ah, the monthly application freeze festival. Right on schedule, like a German train. That a 1-cup problem, not a 3-cup crisis. Let me guess, they also said it was working fine last month. Zara laughs, those exact words. But this time it seems more widespread. Users report the application completely locks up. No error messages, no blue screens, just frozen screens and unresponsive mice. Forced closing doesn't work, and some had to hard reboot. Is it serious? Marcus sits down his coffee. Windows freezes are like car trouble. Could be just a loose gas cap causing your check engine light. Or it might be a blown head gasket. The trick is knowing how to diagnose which type of problem you're dealing with before you start taking apart the engine. Zara pulls out her tablet and opens her Notes app. I've dealt with small application crashes before, but these complete freezes have me stumped. Where do we even start? Marcus smiles. Start by understanding what we're actually looking at. There's a world of difference between an application freeze, a system hang, and a blue screen. Today, I'm going to show you how to tell them apart and fix each one. Consider it your crash course in crash debugging. Zara, eagerly, perfect timing. I've been wanting to learn more about Windows debugging. My certification exam has a whole section on system reliability troubleshooting. Marcus stands up. Let's head over to the finance department and see this freeze in action. Bring your laptop. We're going to collect some data and maybe take a memory dump if we're lucky enough to catch it freezing. Zara gathers her things. Lucky to see a freeze? That's a strange perspective. Marcus grabs his toolkit flash drive. When you've been doing this as long as I have, you start to appreciate the crashes you can observe firsthand. They're much easier to solve than the ones users describe 3 days after they happened. It's like diagnosing engine trouble. I'd rather hear the knock myself than have someone try to mimic the sound. 2. The foundation. Finance department, 8:45 a.m. Marcus and Zara stand behind a user's desk, watching her work with the accounting application. Marcus, all right, before we see the freeze, let's establish some basics. Zara, what's your current process when a user reports their computer is frozen? Zara, thinking. Well, I usually ask if they can move their mouse, if any programs are responsive, or if they can open Task Manager with Control plus Alt plus Delete. Then I check if it's just the application or the whole system. Marcus, good start. Think of it like troubleshooting a car that won't move. First, you check if the engine is running at all, then you see if it's in gear, then you check for more complex issues. Let's formalize your approach with a structured method. Zara, taking notes? Okay, I'm following. Marcus, when dealing with freezes, we need to identify 3 things. First, what exactly is frozen? An application, multiple applications, or the entire system? Second, is it repeatable or random? And third, is it happening on one computer or many? Zara, nodding, that makes sense. For this finance issue, it seems to be just their accounting application. It happens during month-end processing, and it's affecting multiple users. Marcus, exactly. Now, we have 2 main types of application hang problems. The first type is when an application hangs in a single system call. That's like a car stuck at a red light. The program made a request to the operating system, but never got a response back. Zara, so the application is waiting for the OS to do something? Marcus, precisely. The second type is when the application gets caught in an infinite loop or recursion, like a car stuck driving in circles in a roundabout, never taking an exit. Zara, drawing a quick diagram in her notes. Okay, so either waiting for a response or stuck in a loop. How do we tell which is happening? Marcus, that's where our diagnostic tools come in. Windows has built-in systems for tracking and reporting these events. The first place to check is always the event viewer. Marcus logs into the user's computer with admin credentials and opens Event Viewer. Marcus, let me show you how to quickly find freeze-related events. For application freezes, we look in 2 main places: the application log for application hangs and crashes, and the system log for resource or driver issues. Marcus navigates through Event Viewer. Copy. 1. Press 1 plus or to open Run dialog 2. Type Event for the MSC and press Enter 3. Navigate to Windows Logs Application 4. Filter current log by event level, error, and critical. Marcus, see these events with ID 1002? Those are application hangs. And look at the source, application hang, pretty straightforward. The description even tells you which application and version had the problem. Zara, peering at the screen. So this log shows exactly when the application froze and which one it was. That's useful. Marcus, but Event Viewer is just the starting point. Think of it like the check engine light in your car. It tells you there's a problem, but not necessarily what caused it. For that, we need more specialized tools. Zara, what tools should we use? Marcus, let me introduce you to a suite of tools I call my diagnostic pit crew. First up is Reliability Monitor. It's like the car's maintenance history. Marcus opens Reliability Monitor. Copy. 1. Press 1 plus R2. Type perfman/rel and press enter. Marcus, this shows you a timeline of application crashes, hangs, and other stability issues. See how it groups problems by day and type. You can click on any event to see details. Zara, impressed. This is much more visual than Event Viewer. I can actually see patterns over time. Marcus, exactly. And now let's check Performance Monitor to see if there are any resource issues happening when the freezes occur. Copy. 1. Press 1 plus R2. Type perfman/report and press enter. Marcus, this runs a 60-second diagnostic that collects comprehensive system metrics. It's like hooking up a diagnostic computer to your car's ECU. They wait as the report generates. Zara, watching the progress bar. What kind of resource issues could cause freezes? Marcus, several things. CPU maxing out, disk I/O bottlenecks, memory leaks, or excessive paging. The accounting application might be trying to process too much data at once during month end, but there could be a bug causing it to leak memory. Zara, a memory leak? Like it keeps asking for memory, but never gives it back? Marcus, nods exactly. Think of it like borrowing books from a library, but never returning them. Eventually, you run out of space at home, and the library runs out of books. The Performance Monitor report completes. Marcus, now we can see CPU usage, disk activity, memory usage, and network performance at a glance. Look at this memory section. See how the available memory keeps decreasing over time when they run their reports? That points to a potential memory leak. Zara, making note. So we've identified the issue is specific to one application, happens during memory-intensive operations, and possibly involve a memory leak. What's our next step? Marcus, now we need to prepare to capture more detailed information next time it happens. Let's set up some advanced monitoring tools and show the users how to create a memory dump when the application freezes. 3. The challenge escalation. IT department workshop room, 10:30 a.m. Marcus has set up a test environment with the finance application installed. Multiple monitors display different diagnostic tools. Marcus, now we're going to dig deeper. Let's create a proactive monitoring setup that will help us catch the freeze in action and capture all the forensic evidence we need. Zara, like setting a trap for the freeze? Marcus smiles exactly, like setting up trail cameras to catch a rare animal. First, we'll use Microsoft's built-in data collector sets to continuously monitor system performance. Marcus opens a command prompt with administrator privileges. Marcus, this command creates a data collector set that will run in the background and collect comprehensive system metrics every 5 minutes. Copy. Logman create counter finance _long. udomain /administrator *fbin circ vmmehmm max 500c / logical disk */ memory / network interface */ pag ing file */ physical disk */ process */ redirector */ server */ system */ te arminal services */ processor */ cache Sigh, 5 minutes. Zara, trying to follow along. Wow, that's a complex command. What's all this data go to tell us? Marcus, Everything from disk performance to memory usage, CPU utilization, and even network activity. It's like having sensors on every component of a car's engine. We'll also set up a shorter interval collector for when users report active problems. Copy. Logman create counter finance underscore short. udomain / administrator asterisk. F bin circ. VMMDHHMM. Max 500C / logical disk asterisk / memory / asterisk / network interface asterisk / pag ing file asterisk / physical disk asterisk / process asterisk / redirector / server asterisk system asterisk tar min all services asterisk processor asterisk cache asterisk aside 10 seconds. Zara. And this one collects data every 10 seconds instead of 5 minutes? Marcus. Correct. Then we start or stop the collectors with. Copy. Logman start finance underscore long logman. Stop finance underscore long. Zara. Making notes. Where does all this performance data get stored? Marcus. By default, in C:\perflogs. But capturing performance data is only part of the solution. We also need to prepare for memory dumps when an application freezes. Zara, I've heard of memory dumps for blue screens, but can we get them for application freezes too? Marcus, absolutely. There are different types of memory dumps. For blue screens, Windows creates system memory dumps automatically if configured correctly. For application hangs, we can create process dumps manually. Marcus opens system properties on the test machine. Copy. 1. Right-click on this PC Properties 2. Click on Advanced System Settings 3. Under Startup and Recovery, click Settings. Marcus, this is where you configure system crash dumps. See these options? Small memory dump, kernel memory dump, complete memory dump, and automatic memory dump. Each captures different amounts of information. Zara, which one should we use? Marcus, for serious troubleshooting, I prefer complete memory dumps. They contain everything in physical memory at the time of the crash. But they're also very large, equal to your installed RAM, plus a little overhead. Marcus changes the settings to complete memory dump and ensures there's a system-managed page file on the system drive. Zara, so this will create dumps for blue screens, but what about application freezes? Marcus, for that, we need to use tools like Process Explorer or create dumps on demand. Let me show you how to enable a keyboard shortcut that can force a blue screen dump, sometimes useful in extreme cases. Marcus opens Registry Editor. Copy. 1. Navigate to HKY_local_machine /system /current control set /services /I8042 PRT /parameters 2. Create a new DWORD value. Name, crash on control scroll, value, 13. Navigate to HKY_local_machine /system /current control set /services /did /parameters 4. Create the same DWORD value there. Marcus, after a reboot, this enables a keyboard shortcut, right control plus scroll lock twice, that forces a blue screen and creates a memory dump. It's our emergency ejection handle, but use it wisely since it will crash the whole system. Zara, concerned, that seems pretty drastic. Wouldn't that cause data loss? Marcus, it's a last resort when a system is completely hung and you need diagnostic information. Now, let's look at a less nuclear option for application freezes. Marcus downloads and installs Process Explorer from the sysinternal suite. Marcus, Process Explorer is like having X-ray vision for running applications. When an application freezes, we can create a process dump without crashing the system. Marcus demonstrates by right-clicking on a running process and selecting Create Dump, Full Dump. Zara, that creates a dump of just that one application? Marcus, exactly. It captures everything about that process. Its memory, threads, handles, everything. Think of it like taking a snapshot of just one component in the engine while it's failing. Zara, so if the accounting application freezes, we can create a dump using Process Explorer and then analyze it later? Marcus, precisely. And speaking of analysis, let's download some specialized tools for that part of the job. Marcus goes to the Microsoft website and downloads the debugging tools for Windows, which includes WinDBG. Marcus, WinDBG is the master key to unlock what's happening in memory dumps. It's not the most user-friendly tool, but it's incredibly powerful. Zara, looking at the complex interface, I can see that it looks intimidating. Marcus, let's also get some tools from Nearsoft that make dump analysis more accessible. Marcus downloads Blue Screen View and What is Hang. Marcus, Blue Screen View lets you analyze blue screen dumps with a simple interface. What is Hang helps identify what's causing an application to hang. They're like the specialized tools in a mechanics toolbox. Each has a specific purpose. Zara, so we have tools to monitor performance, create dumps, and analyze those dumps. How do we tie all this together when a real freeze happens? Marcus, that's our next challenge. Let's create a procedure for the finance team to follow when they experience a freeze, and then we'll set up a test scenario to practice our analysis. 4. Guided practice. Finance department, 1:15 p.m. Marcus and Zara are setting up a workstation with the monitoring tools. Marcus, now let's put everything together into a practical workflow. I've created this document for the finance team to follow when they experience a freeze. Marcus shows Zara a one-page guide with screenshots. Marcus, it instructs them to note what they were doing when the freeze occurred. Try basic troubleshooting like waiting 60 seconds and try Control plus Alt plus Delete, and if that fails, to call us immediately while keeping the frozen application open. Zara, this is great. Clear steps without overwhelming them with technical details. Marcus, now let's simulate a hang situation and practice our analysis. I've written a small program that will deliberately freeze after processing a large data set, similar to what might be happening with their accounting software. Marcus runs the test application and triggers the freeze condition. Marcus, now the application is frozen. Let's follow our own procedure. First, we'll capture a process dump using Process Explorer. Marcus opens Process Explorer, finds the hung application, right-clicks it, and selects Create Dump, Full Dump. Copy. 1. Launch Process Explorer as Administrator 2. Find a frozen process in the list 3. Right-click on the process 4. Select Create Dump, Full Dump 5. Choose a location to save the dump file. Marcus, now we've captured the state of the application at the exact moment it was hung. Next, let's use What is Hang to get a quick analysis. Marcus opens What is Hang and points it to the frozen application. Marcus, see how it shows us the strings found in the stack and the modules loaded by the application? It's already telling us that this hang is likely due to a function called Process Large Data Set that's stuck in an infinite loop. Zara, that's much easier to read than I expected. So What is Hang is good for quick analysis of hung applications? Marcus, exactly. Now let's take a deeper look using WinDBG. This is where things get more complex, but also more powerful. Marcus opens WinDBG and loads the process dump they just created. Copy. 1. Launch WinDBG x64 as Administrator 2. Click on File, open Crash Dump 3. Navigate to and select the dump file 4. Wait for the dump to load. Marcus, first, we need to set up the symbol path so WinDBG can understand what it's looking at. Copy. .sympath srv *c \symbols *https //msdl.microsoft.com/download/symbols.reload. Zara, what are symbols? Marcus, think of them as the legends on a map. They tell the debugger the names of functions, variables, and other important landmarks in the code. Without symbols, we just see memory addresses with no context. Zara nods, that makes sense. So what do we look for next? Marcus, let's run the analyze command to get an automated analysis. Copy. Analyze v. WinDBG displays a detailed analysis of the hang. Marcus, look at this output. It's showing us the exact line of code where the hang occurred, the call stack that led to it, and even some suggestions about what might be wrong. Zara, looking at the screen, it's pointing to a loop in that process large data set function where it's checking for a condition that never becomes true. Marcus, good catch. That's exactly the issue. Now let's look at the threads to see what else was happening. Copy. Kuba. Marcus, this command shows the call stack for all threads in the process. Sometimes a hang isn't in the main thread, but in a worker thread that the main thread is waiting for. Zara, studying the output, I see several threads, but it looks like thread 3 is the one stuck in that processing loop. Marcus, excellent observation. Now let's look at the local variables in that thread to see what might be causing the infinite loop. Copy. 3s.frame4dv. Marcus, these commands switch to thread 3, move to frame 4 in the call stack, which is where the processing function is, and display local variables. WinDBG shows the variable values. Marcus, look at this. The variable max iterations is set to -1, which would cause the loop to run forever since the iteration counter will never reach it. Zara, excitedly. So the application is freezing because of a programming error, a loop condition that can never be satisfied. Marcus, precisely. Now we've diagnosed the exact cause of the hang. In a real scenario, we'd report this to the software vendor with our findings. Zara, this is amazing. I never realized we could dig so deep into a frozen application. Marcus, the tools make all the difference. Now let's practice one more scenario. Analyzing a system-level memory dump from a blue screen. Marcus loads a previously saved memory dump from a blue screen event. Marcus, for system dumps, the process is similar, but we're looking at the entire operating system state. Let's see what caused this crash. Copy. Analyze. WinDBG shows a driver-related crash. Marcus, see how it identified a specific driver as the likely cause? Now we can look at the driver stack to confirm. Copy. LMVM faulting _driver _name. Marcus, this command tells us more about the driver, its version, timestamp, and other details. From here, we typically check for driver updates or remove problematic drivers. Zara, taking notes. So for application hangs, we use process dumps and focus on the application code, while for system crashes, we use memory dumps and look for driver or hardware issues. Marcus, that's a good summary. The principles are the same, but the scope is different. It's like diagnosing a problem with one specific component versus troubleshooting the entire engine. Zara, I think I'm starting to understand the methodology, but there's still so much to learn about interpreting the results. Marcus, that comes with practice. The more dumps you analyze, the better you'll get at recognizing patterns and understanding what the data is telling you. 5. The complexity crucible. IT department. Next day, 9:30 a.m. A finance user has reported that the accounting application froze during a month-end process, and they followed the procedure to keep the application open. Marcus and Zara are at the user's desk. Finance user. It's been sitting like this for 20 minutes. I can use other applications, but this one won't respond at all. Marcus, perfect. You did exactly what we asked. Now we can capture a live dump of the problematic application. Marcus runs Process Explorer and creates a dump of the frozen accounting application. Zara, to the user, you can force close it now if you'd like. We've captured what we need to investigate. Marcus, let's head back to our workshop to analyze this. This is where things get interesting, a real-world problem rather than our test scenario. Back in the IT workshop, they begin analyzing the dump. Marcus, let's start with what is hang for a quick overview, then move to WinDBG for deeper analysis. Marcus opens what is hang and loads the dump. Marcus, interesting. It's showing that the application is stuck in a system call, not an infinite loop like our test case. It's waiting for a database response that never came back. Zara, so this is the first type of hang you mentioned, stuck waiting for a response? Marcus, exactly. Now let's confirm with WinDBG. Marcus opens WinDBG and loads the dump, setting up the symbol path. Copy. Sympat serve wjeżdżka symbols wjeżdżka http zdwojteczka lomitko msdl microsoft.com lomitko download lomitko symbols reload analyze. Marcus, the analysis confirms it's waiting on a database call. Now let's look at all the threads to see what else is happening. Copy. Kuba. Zara, scanning the output. Wow, there are a lot more threads than in our test application. Marcus, enterprise applications often use thread pools and multiple worker threads. Let's focus on the main UI thread since that's what's frozen. Copy. 0skb. Marcus, the main thread is waiting on a synchronization object, probably waiting for the database thread to return results. Zara, so the root cause might not be in the application itself, but in the database it's trying to communicate with? Marcus, that's a good hypothesis. Let's check for any network or database connectivity issues. Marcus opens another command prompt and runs some network diagnostics. Copy. Netstat. Ono Finster SQL ping database _server _name. Marcus, these connections to the SQL server look normal. Let's check the SQL server itself. Marcus opens SQL Server Management Studio and connects to the database server. Marcus, let's check for blocking locks or long-running queries. SQL. Copy. Select r.session_id, r.status, r.blocking_session_id, r.wait_type, r.wait_time, r.last_type, t.textFromSys, _request, r cross-apply sys, _text, r.SQL_handle. T where r session_id greater than 50 order by r session_id. Zara, eyes widening. There it is. A query from the accounting application has been running for over 30 minutes, and it's being blocked by another session. Marcus, good catch. And look at the blocking session ID. It's another process from the same application. Let's check what that session is doing. SQL. Copy. Select r.session_id, r.status, r.wait_type.
ايوه دقيقة واحدة. So let's continue guys, sorry.
Oing. SQL. Copy. Select r.session_id, r.status, r.wait_type, t.textFromSys, request, r cross-apply sys, text, r.SQL_handle. T where r session_id equals blocking_session_previous_query. Marcus. I see the problem now. This blocking session is running a large transaction that's holding locks on tables the other query needs. And it looks like it's part of an automated monthly report. Zara, so the application freeze is actually due to a database blocking issue? Marcus, exactly. The application isn't coded to handle this scenario gracefully. It just waits indefinitely for the database to respond, making it appear frozen to the user. Zara, thinking. So we have two options. Fix the database blocking issue or modify the application to handle waiting better. Marcus, that's right. Since we can't modify the application code ourselves, let's focus on the database side. We could add appropriate timeouts to queries, improve the indexing on frequently accessed tables, schedule the automated reports during off hours, configure the transaction isolation level to reduce blocking. Zara, this is fascinating. We started with what looked like an application problem. Marcus, that's why we need this whole toolbox of techniques. Use memory analysis tools to trace it to a database call and ended up finding a database configuration issue. Marcus, that's why we need this whole toolbox of techniques. Problems rarely stay in neat categories. They flow across systems and dependencies. Zara, excited. Let's implement some of those database changes and see if they resolve the freezing issue. Marcus, great idea. But first, let's capture one more thing, a baseline performance recording when the system is working correctly. That will help us confirm our fixes actually improve things. Marcus sets up a performance monitor recording with key database and application metrics. Copy. Logman create counter div_score baseline. udomain /administrator asterisk fbin vmdhmm c // process left parenthesis SQL server /asterisk // server locks /asterisk // server weight statistics /asterisk logical disk asterisk memory asterisk sci 30 seconds logman start db_baseline. Marcus, we'll let this run for a few hours during normal operation, then compare it to recordings taken after our changes. Zara, I'm amazed at how we've gone from a simple application is frozen complaint to performing SQL query analysis and capturing performance baselines. It's like peeling layers of an onion. Marcus smiles, that's troubleshooting for you. You never know how deep the rabbit hole goes until you start exploring, which is why having the right tools and methodical approach is so important. 6. The integration. IT department, 1 week later. Marcus and Zara are reviewing the results of their changes. Marcus, it's been a week since we implemented those database optimizations. Let's look at the metrics and see how we did. Marcus opens Performance Monitor and loads comparison reports from before and after their changes. Marcus, look at these blocking statistics, down by 95%, and the accounting application hasn't had a single reported freeze incident. Zara, proudly, the finance team actually sent us a thank you email yesterday. They said month-end processing is running twice as fast now. Marcus, let's consolidate what we've learned about troubleshooting Windows freezes and lockups. Want to summarize the approach? Zara, confidently. I'd break it down into these steps. Identify the scope. Is it an application, multiple applications, or the entire system? Check Event Viewer for application hang events, ID 1002, and other errors. Use Reliability Monitor to see if there's a pattern over time. Use Performance Monitor to check for resource issues. For application freezes, capture a process dump using Process Explorer. Analyze with WHAT-IS-HANG for a quick overview. Use WinDBG for deeper analysis if needed. For system freezes, configure memory dumps appropriately in system settings. Analyze dumps with Blue Screen View or WinDBG. Look for driver issues or hardware problems. Remember that the cause might be external, like our database blocking issue. Implement solutions and measure their effectiveness. Marcus, impressed. That's an excellent summary. I'd add one more thing, documentation. Record what you find, what you tried, and what worked, so you can build your own knowledge base over time. Zara, actually, I've been working on that. Shows tablet. I've created a mind map of everything we've covered with links to commands, tools, and example analyses. Marcus, this is fantastic, Zara. Mind if I share this with the team? Zara, not all. I actually have a question about something we haven't covered yet. What about kernel-level debugging? When will we use that? Marcus, that's the next level of depth, typically used for driver development or investigating very low-level issues. It involves connecting two computers, one running the debugger and one being debugged, usually via a serial or network connection. Zara, could we set up a demonstration sometime? I'd love to learn about that too. Marcus, absolutely. I'll set up a lab environment next week and we can walk through it together. It's more complex to set up, but it's incredibly powerful for certain types of problems. Zara, excited. I can't wait. This whole experience has completely changed how I think about troubleshooting. It's not just about fixing the immediate problem anymore. It's about understanding the whole system and its interconnections. Marcus, smiling. Now you're thinking like a seasoned IT professional. Troubleshooting isn't just a technical skill, it's a mindset. And from what I've seen this week, you've definitely got it. Zara, thanks, Marcus. I couldn't have asked for a better mentor for this. So what's our next case? Marcus, laughs. Let's enjoy this victory for at least a day before looking for more problems to solve. But speaking of next steps, let's set up that virtual lab environment I promised so you can practice these techniques on your own.
So this is a case, okay, I think it is very, very good how to explain the freeze situation, and at the end, the finance application freeze was because of an access to an external database. As we can see here, this was elaborated and explained uh, very good, and we can see the last step here I stopped because this is a virtual lab demonstration. If you need to experience all of this case in a virtual environment, here are the steps created by the AI. Okay, some PowerShell tools or PowerShell commands to create new VMs in Hyper-V, and then some scripts to create a hang situation, and a couple of things. For example, let me show you. So these are all scripts to create a hang, and then some scripts to analyze database or SQL analyze the SQL database, trying to imitate the situation that was created before. Okay, so as we can see here, these are all things here, or these are all steps to create a virtual environment to explain this case or to have this case simulated. Okay, all of these are scripts, and at the end, if you try to see that, all of these are written. If you go further down, here are all of the scripts. Okay, when you use to start fresh, here you go, there is application freeze simulator, and then we have configure complete memory dumps, and then we have crash dump analyze script, virtual lab script setup. Okay, so I think this is an automation of creation of some virtual machines, I think, but using Hyper-V. Okay, and at the end, some SQL blocking simulator. I think this to simulate the SQL database issue that was confronted by the finance team. So as you can see here, very good example and very simple to follow. Okay, I can show you another case also created by Claude. Okay, also another case concerning a junior and a senior IT. Let's try to see also this case and see how this is or how this help us to explain this topic. If we go further and try to read this case or try to read it, so here we go, let's try to read it loudly.
Sue's in the future. Would you like to discuss any specific aspect of this troubleshooting approach in more detail? Retry. Claude can make mistakes. Please double-check responses. Windows applications lockup and freeze troubleshooting session. Phase 1. Concept explanation. Senior IT. Today we'll be diving into Windows applications and system freezes, a common issue you'll face as an IT administrator. Before we get started, can you tell me what you understand about Windows freezes or lockups? How would you explain what they are, what causes them, and the general troubleshooting approach? Junior IT, simulated from what I understand, a Windows freeze is when an application or the entire operating system becomes unresponsive. The cursor might still move, but I can't click on anything or interact with Windows. Sometimes it's just one application that freezes, while other times the whole system locks up. I think freezes are usually caused by software bugs, memory issues, or maybe drivers that aren't working correctly. When troubleshooting, I usually start by trying Control plus Alt plus Delete to open Task Manager and in the frozen process. If that doesn't work, I might have to force a reboot. I'm not really sure about more advanced troubleshooting methods though. Senior IT. That's a good foundation, but let's expand on it. You're right that freezes can be either application-specific or system-wide. Let me clarify a few points. There are actually two primary types of application hang problems. Single system / kernel / API call hang. This happens when a program makes a request to the operating system, like opening a file, but the system function never returns, causing the program to appear frozen while waiting. Infinite loop or recursive call hang. This occurs when the application gets stuck in code that repeats endlessly or calls itself recursively without proper termination conditions. As for causes, you mentioned several good ones. Let me add more context. Software bugs can cause deadlocks where two processes each hold resources the other needs. Driver issues, especially with graphics or storage drivers. Insufficient system resources, RAM, disk space, CPU. Hardware problems, failing disk, memory issues. Malware. Network timeouts when applications are waiting for remote resources. For troubleshooting, there's a systematic approach that goes well beyond Control plus Alt plus Delete. Identify the scope. Is it system-wide or just one application? For still responsive systems, try accessing via remote desktop / admin shares. Use Task Manager to check resource usage. Examine event viewer logs for errors. Use Performance Monitor to identify bottlenecks. Test system controls. Control plus Alt plus Delete response. For systems that have recovered, analyze system and application event logs. Generate system diagnostics reports with Perfman/report. Check reliability monitor for crash patterns. Use specialized tools like Blue Screen View or What is Hang. For deeper analysis, configure and collect memory dumps. Use debugging tools like WinDBG. Monitor memory pool usage. Can you walk me through how you'd approach a freezing issue on a user's workstation, given what I've just explained? Junior IT, simulated IC. So there's much more to it than I initially thought. Let me try to apply this to a scenario. If a user reported their workstation freezing, I would first ask clarifying questions. How often does it freeze? Is it the entire system or just certain applications? What were they doing when it froze? Does it happen to anyone else? If the system is currently frozen but still partially responsive, try connecting remotely through remote desktop or admin shares. Check resource usage in Task Manager if I can access it. Try opening Event Viewer to look for recent errors. Use Performance Monitor to see if there are any obvious resource bottlenecks. If the system has already recovered, look through Event Viewer for application and system logs around the time of the freeze. Run Perfman/report to generate a system diagnostics report. Check reliability monitor to see if this is a recurring issue with patterns. If it's a recurring issue that needs deeper investigation, configure the system to generate memory dumps when crashes occur. Consider setting up data collector sets to monitor performance during the problem. Maybe use those specialized tools you mentioned like What is Hang. Is this approach on the right track? I'm not familiar with configuring memory dumps or using debugging tools though. Senior IT, that's excellent progress. You've laid out a solid troubleshooting approach that covers many of the key steps. Let me fill in some additional details and address the areas you mentioned you're less familiar with. Your approach is definitely on the right track. The questions you'd ask the user are crucial. They help narrow down the problem pattern and potential causes. I would add one more important question. Have there been any recent changes to the system, like software installations, updates, or hardware changes? For memory dumps and advanced debugging, here's what you should know. Configuring Windows for memory dumps. Open System Properties, sysdm.cpl. Go to Advanced tab Startup and Recovery Settings. Under Write Debugging Information, Select the type of memory dump. Small memory dump, 64K. Smallest, least detail. Kernel memory dump, medium size, good detail for most issues. Complete memory dump, largest, most comprehensive, but requires more disk space. Ensure automatically restart is checked if you want the system to reboot after a crash. For manual crash dumps, you can enable keyboard trigger dumps by adding registry keys. Copy. HK1_local_machine /system /current control set /services /I8042 PRT /parameters HKY_local_machine /system /current control set /services /did /parameters value name. Crash on control scroll data type. Reg_d word value. This lets you force a crash dump by holding right control and pressing scroll lock twice. For application freezes specifically, Process Explorer from sysinternals can create process dumps of hung applications. What_is_hang from Nearsoft can detect which process is hanging and provide information about it. For working with memory dumps, first validate dumps with dumps.chk.exe to verify they're readable. For simple analysis, Blue Screen View can show key information about crash dumps. For deeper analysis, WinDBG is the tool of choice. Set up symbol path with .sympathrv *c //https://msdl.microsoft.com/download/symbols. Load the dump file and run. Analyze. V for automated analysis. Look at the stack trace with K command to see what was happening at crash time. Let me illustrate this with a workflow diagram. Copy. User reports system freeze, system currently frozen. Yes, try remote access, remote desktop, admin shares. Check resource usage. Event logs, no. Analyze event logs, generate system diagnostics report. Perfman/report. Check reliability monitor, is it recurring/serious? Yes, configure for memory dumps, set up performance monitoring, consider specialized tools. Process Explorer, what_is_hang. After collecting data, validate dumps with dumps.chk, analyze with Blue Screen View. Simple, or WinDBG. Advanced, look for patterns in logs/dumps to identify root cause. Does this help clarify the process? Do you have questions about any of these specific tools or techniques? Phase 2, Practical Application Scenario. Senior IT. Now let's apply this knowledge to a real scenario. Scenario. A user from the accounting department reports that Excel freezes every time they try to open a specific spreadsheet. The freeze happens after about 30 seconds of working with the file. When Excel freezes, they can still use other applications, but Excel becomes completely unresponsive and they have to force close it through Task Manager. This is happening consistently with this one file. What would your troubleshooting approach be? Junior IT, simulated for this Excel-specific freezing issue, I'd approach it as follows. First, I'd gather more information. Ask if this happens with other Excel files or just this one specific spreadsheet. Find out if anyone else can open the file without issues. Check when the issue started and if there were any changes, Excel updates, file modifications. Ask about the size and complexity of the spreadsheet, large datasets, complex formulas, macros. Initial troubleshooting. Try opening the file in Excel safe mode. Hold Control while launching Excel. Attempt to open a copy of the file to rule out file corruption. Check if Excel has all available updates installed. Look at Event Viewer logs for application errors related to Excel. If the issue persists, use Process Explorer to monitor Excel's resource usage when opening the file. Create a process dump of Excel when it freezes. Check if add-ins might be causing the issue by disabling them. Advanced troubleshooting. Use what_is_hang to get details about what Excel is trying to do when it hangs. Analyze the Excel process dump to see what was happening at the time of the freeze. I believe this is likely an application-specific issue rather than a system-wide problem, since it only affects Excel and only with a specific file. The most likely causes might be file corruption, problematic macros, or an Excel add-in that's not handling something in the file correctly. Senior IT, great approach. You've outlined a methodical troubleshooting process that focuses on the specific nature of this issue. Let me provide some additional insights and techniques. Your initial information gathering is spot on. Application-specific issues like this often have very specific triggers, and you've identified the right questions to narrow it down. For your troubleshooting steps, I would add or modify a few things. File-specific investigation. Try to recover data from the problematic spreadsheet by opening it in Excel online, if available. Use Excel's built-in repair feature. File Open Browse, select File drop-down next to Open button, Open and Repair. Extract data only without formulas/macros to see if the core data can be salvaged. Enhanced monitoring. Use Performance Monitor to create a targeted data collector set specifically for Excel. Copy. Logman create counter Excel monitor. udomain /username. fbincirc. vmmdhmm. max 500c /process. Excel asterisk. /*memory /physical disk asterisk psi 5 seconds. This will capture Excel's performance metrics at 5-second intervals. Start this collector before opening the problematic file. Logman start Excel monitor. Advanced dump analysis. When collecting a dump of the frozen Excel process, use Process Explorer with these steps. Right-click on the Excel process. Select Create Dump, Create Full Dump. This generates a user mode dump file that contains more information than a mini dump. Analysis with WinDBG. Load the dump file in WinDBG. Run, Analyze, V for automatic analysis. Check the call stack with K command to see where Excel was when it froze. Look specifically for Excel add-ins or third-party components in the stack. Check COM objects with COM calls. Office-specific diagnostics. Consider running Office in verbose logging mode. Copy. Excel.exe/safe. Review Office logs at %localpappeta%\office\version\telemetry. Use Microsoft Support and Recovery Assistant, SARA, tool to diagnose Office issues. The issue is likely caused by one of these. Corrupted content in the specific cell or range. An Excel add-in that conflicts with something in the file. A complex calculation or macro that's creating an infinite loop. External data connections that are timing out. For issues like this, sometimes the fastest solution after determining the root cause is to create a new spreadsheet. Copy data in sections from the original to the new file to identify the problematic section. Rebuild any complex formulas or macros. Your approach demonstrates good analytical thinking. Remember to document each step of your troubleshooting process, as this will help both with current resolution and any similar issues in the future. Would you like to discuss any specific aspect of this troubleshooting approach in more detail?
So as you can see here, this is another very good case concerning the freeze situation. This is the freeze with Excel, and he giving us a lot of useful techniques to solve an Excel hanging situation, and the other case, how to solve a freeze concerning a database or SQL database freeze. As we can see here, both are very good and give us a lot of scripts and tools to analyze the freeze situation. So I think this is very good case. As you can see, Claude is very its advantage is to provide scripts, and I think these two cases are very creative. So with God will, until the upcoming video, we will talk about another topic. Let's hope this will be good. Hope this video is informative for you all, and thank you all for viewing. Thank you so much.